one of the things we're trying to do is just literally help support and save American manufacturing, is that now we can do this by bringing automation and measurement together. We can do this with machinery and with robots. And so we can spend the time for operators to be able to be significantly more efficient and be able to take on more and more and get more done in an hour. But what does all that mean to us as consumers? The big deal is going from measuring 10% of the thing, so maybe there is a 10% chance that what I grab off the shelf was actually measured, to now we can do things 100% inspection, right? All the innovation and time and energy was spent on making things more and more accurate. And then we realized, wow, we're accurate enough. We can make really good decisions. But now we need to think about how do we get it out of the lab onto the plant floor?
That's the next step.
We're bringing those two things together now. So tell us what's going on right now. What's kind of on the leading edge of the plant floor? Hey, everybody. Welcome to episode 15 of Innovating the Industrial World, our podcast where we talk about all the cool things that we're doing here at Cross. And I'm here to talk with Chris Johnson and Will Nicholson about the confluence of two different industries that are really coming together in terms of technology advancements to make our lives significantly better. And that's the precision measurement world and measurement and inspection, and the automation world have really come together. So let's talk a little bit about that. Chris, you want to introduce yourself?
Yes, I'm Chris Johnson. I'm the product manager with the Precision Measurements Group, specializing in multi-sensor metrology devices.
And Will?
My name is Will Nicholson. I'm the mechanical engineering manager with the automation group at Cross. I've got a background, obviously, in automation as well as a lot of precision measurement and gauging also.
This is really cool because this is a lot of fun. There's lots of things that have happened in these industries to bring it together. So tell us what used to be the case. How did we do measurement and inspection in the manufacturing world 10, 15 years ago, Chris?
Right. So in the manufacturing world, we used to do things manually. We would use a lot of hand tools, a lot of calculators and things of that nature, and we would do them in large batches, but we would also do them in a lab. We'd set up and take 15, 20, or 30 parts to a lab and drop them off and wait for them to come back because the manual process just takes time.
So all the things we use and buy are manufactured by people, and they come out on a production line. And a long time ago, we used to have to go, okay, we're going to grab 10% of these or 15% of these, take them back to the lab, take micrometers and calipers and thread gauges and things like that to say, okay, is this to spec? Because we're the folks who use these things, and there's safety reasons safety impacts on that. We need to make sure that whatever we get, whatever we're using, is built to its design and built to spec.
That's right.
And so, a long time ago, we used to do that manually, right? And that would take a while.
It would take a while. So it would actually take longer to measure the parts than it would be to make the parts. So we would take parts at, like say 10 or 15 of them, we drop them off to a group of people and say, here we go, I'll wait for you to give me the data back so I can keep manufacturing to tell if I'm making good parts or not.
And hold that thought, because if we're measuring it and it's good, great, we get to keep making them. But if you measure them and it's bad, then we got to make some decisions. But Will, tell us what was going on in the automation world 10 or 15 years. There's been a lot of innovation.
Sure, yeah. So certainly back in the day of automation, I'll use robots as an example.
Like this one right here.
Like similar to this one. Your robots were big, heavy. I won't say not safe, but certainly required separation from people to make sure they don't
you can work right
injured.
alongside this thing. If this thing moves over here and touches one of us, it's going to stop.
Yeah, exactly. So that's one of the big changes is these newer robots, the cobots, collaborative robots specifically. They've got newer sensors, better sensor technology that can detect, if they're bumping into something they're not supposed to, that they can stop so that someone doesn't get potentially hurt or injured by them. So that's a big change and improvement over the past couple of decades.
But imagine how, almost like science fiction, how expensive it would be to have a machine grab 10 parts, take them to a lab, and then measure them. Because back then you had all you know is you didn't really have the sensors to be able to tell what was going on with that thing. And now there's been a lot of innovation in that.
Yeah, exactly. Certainly with gripping technology, there's a lot more. There's a lot of innovations in being able to easily, softly grab certain types of parts or different shape parts. That's a big improvement as well. So you can pick out a specific part to do something with it, to add some process to it, or to measure it, as we're talking about today. That's a big improvement over the last.
So what's going on, Chris, in terms of the technology and the measurement and inspection world to get us where we are today? That's
right. Right. So where we are today, we've been able to add motors to gauges and make them move in an automated fashion. They're programmable. The advent of the PCs and software and the advancements in those chipsets allow us to bring in CAD models to work with, so that we can measure parts and compare them back to a perfect golden standard, rather than each individual component trying to measure those distinct features, right? So we can look at a mass number of features as a whole, but still it's in a place today where that requires some programming knowledge and some metrology or measurement background and history to understand how to go about having those machines take those measurements.
Yeah, because it's not all that easy, but it is getting
Right.
more and more advanced in terms of software as
Absolutely.
well as.
Absolutely. Software has been the biggest driver over the past decade in measurement. We don't see many new measurement technologies as the technology is done, and what the software can do with these things. They're all tools. And then how can we advance that and get measurements faster and more accurate?
Yeah, and we've been working together a long time, so y'all know I kind of grew up in the measurement world. And so forever, all the innovation and time and energy was spent on making things more and more accurate. And then we realized, wow, we're accurate enough. We can make really good decisions. But now we need to think about how do we get it out of the lab onto the plant floor.
That's the next step.
And making it significantly more robust to be able to handle things, because the plant floor has got a lot going on, right? A lot of vibration, a lot of dust, a lot of things like that.
Right.
But what does all that mean to us as consumers? The big deal is going from measuring 10% of the thing, so maybe there is a 10% chance that what I grab off the shelf was actually measured, to now we can do things 100% inspection, right?
That's correct. That's correct. So we would like to dictate that to 100% inspection, and we want it done at point of use. We want it done during the manufacturing process, so we can capture that data real time rather than waiting till the end of that, where it costs an arm and a leg or what it costs even the customer a potential escape if you wait till the end of the process to do something.
Because at each step of the process, we're putting more and more time and energy into. So if I'm a manufacturer,
That's right.
now I can 100% inspect things at each step of the process. And the other innovations is it's become increasingly, I will say, not necessarily less expensive, but more affordable and usable to be able to have multiple inspection points.
That's correct. That's correct. For the cost of poor quality goes straight into the products that we buy every day. As product gets more and more reliable, more and more dependable, the cost to manufacture that product and to each of us becomes cheaper.
Which way more affordable for us.
That's correct.
Way more dependable. We know that if we get it, it's most likely been inspected now too. And that matters a lot. So these two technologies are coming together to make automation more not only usable and programmable, and the sensors are better, so we can now move things around. And now we have inspection and measurement equipment that can measure things not only accurately, but dependably at each step of the way. And those two things come to which we're bringing those two things together now. So tell us what's going on right now. What's kind of on the leading edge of the plant floor?
So what we're seeing more and more of from the automation and measurement come together standpoint, a lot of times, machine tending is a term you hear commonly thrown around. So a robot is taking a part from some other machine, taking it out of the machine, putting it on a cart or some system to go further downstream to have something else done to it. We're seeing more and more where someone wants to actually measure, verify that part is correct in that step. So instead of just the robot taking it out of the machine and sending it on down the line, it's pulling it out of the machine, inspecting it in some capacity, and then sending it down the line. And if it's bad, we can reject it then, versus waiting until much further down the process to determine it's bad.
So one is I'm a consumer, it's not on the shelf being bad, which is great. But the other thing is, as Chris will tell you in the measurement world, things don't go bad right away. They typically start to get a little bit more and more and more to the edge. And then now if we're doing that 100% of the time, we can give that feedback to the machine that built it, or us as in further upstream in terms of the process, so that we can fix that before something goes bad.
Exactly. Yeah. So we can basically feed that information back in more or less real time, and then make adjustments as needed to make sure the part is always trending and staying in tolerance. Some of the ramifications of that are, you don't have product that you slim down the amount of variation in a product that you might see, in quality that you might see as an end user. that band of tolerance is able to tighten up so that you might not be able to visually see or physically feel a difference in a product by being able to control it more tightly.
Yeah, and viewers, y'all may remember I was a math major, not an engineer, but that's in the statistics world, that's getting in your control limits. And so the more your control limits, the more you can control, the better off your confidence is that when it's on the shelf, it's going to work.
That's correct.
Right?
Yeah, exactly.
And
That's
remember,
right.
I said, hey, you were talking about putting things on the shelf and waiting for them to be inspected. What happens when you do that back in the old days? And what would happen if they were out, if something was wrong, if we measured it and it was not right?
Right. So, well, the first thing is you've got to get a containment mechanism and figure out where are the parts that are wrong that came in before these, what caused this, right? There's multiple avenues you go, which take a great amount of time and engineering resources to find the defects.
Right. So when we were sampling it and sticking it on the shelf, we go, oh my gosh, when was the last time we measured a good part? Now we measured a bad part. What happened in between?
Right.
I don't know if those are good or bad.
Right.
And so we have to go find them. We have to measure them. We have to make sure that they're right. We have to sort them and that kind of thing. And then we're not giving that feedback to the machine either.
You even have to go forward. You have to look at, I just found a bad part. Well, that was 30 parts ago I measured a good one, but when did this defect actually happen? It could have happened the part right after I measured the good one. So now I have parts that have escaped somewhere. I have to go find those and remeasure those as well.
And if they've gotten out of the building or shipped,
Right.
a customer might get one of those things, and that's not good.
Right.
Right? That's not good
correct.
at all. So we can have much greater control over that, and it actually cuts down and makes literally the world better because we can go from some scrap rate to zero scrap.
That's exactly right.
That's the ultimate goal.
In
of
theory,
course. Yep.
that is the
In theory.
ultimate goal.
That's right.
And we certainly make sure that kind of nothing gets out of the plant floor. But there's also another issue going on that we've had another whole discussion on. And in terms of trying to say, as we would call it, one of the things we're trying to do is just literally help support and save American manufacturing, is that now we can do this by bringing automation and measurement together. We can do this with machinery and with robots. And so we can spend the time for operators to be able to be significantly more efficient and be able to take on more and more and get more done in an hour.
That's a huge thing we see with when we're automating some sort of measurement is that oftentimes a person doing that measurement just simply can't do it fast enough. You've got a part coming every 10 seconds, every 20 seconds, some pretty fast cycle time. Even if a person's perfectly technically capable of doing it, they just can't do it that quickly.
Yeah.
So
It's just not humanly possible.
Exactly. If the need is that all the parts get measured, then we're much more easily able to do that through automation versus having to, somehow figure out a way to do it manually more quickly.
Right. And so we're not talking about replacing people. We're just talking about making people be able to get a whole lot more done with the same
Exactly.
That is absolutely true. The advancements that I see, when I listen to you talk about that is, from my manufacturing experience, robots were always so big, bulky, fast-moving, carrying heavy product, and now we see things like the cobot come along that can work right alongside of my manufacturing operators.
Much more nimble.
Much more nimble. I don't have to
Safer,
worry so much about safety and things getting in the way. The cobot is so much more sensitive to what's going on in its environment that it can work with the people rather than working against them.
Yeah. So instead of having, an operator having to do a lot of tedious measurement, that can be done automatically while the operator is, doing something else.
Exactly.
Some material handling. Maybe they're bringing
Exactly.
parts to and from a cell. Maybe they're keeping a check on how things are running. Yeah, exactly.
Or they're managing multiple cells and multiple production lines to make sure that those things are operating well. Great. So as we talk about the kind of current state of the technology, let's talk a little bit about this example here. So Will, tell us a little bit about what this machine's doing.
Yeah, it's a great example. So this is a cobot, and on the end of the cobot is a specific tool, like I was mentioning earlier, kind of some advances in what our tools are able to do, our grippers. It has a thread gauge attached to it, and through some software advancements and sensors, it can actually detect how much torque it takes to drive the thread gauge into a threaded hole. So what we're doing with this robot is actually moving this thread gauge around to all the different holes in this part to gauge and make sure the threads are there and are the correct size and
So
the
all
correct
those
depth.
numbers, this thing's going to go, I'm going to check thread, I'm going to check hole number 1, 2, 3, 4, all those.
Exactly. So every single hole in that part will go through and automatically check to make sure they're the right depth and size.
And Chris, how did we used to do that?
Yeah, so we used to do that manually. I'm having a holding a plug gauge and threaded plug gauge in my hand, and we'd screw this in manually, and to see that it would go in, and then we'd have to unscrew it and then go to the second side, which we have a go and a no-go end. And the no-go end, obviously, if it doesn't go, makes it a good part. Of course, if it went in, then we're back to where we were again.
And here's why we care, because you see this casing here, if that thread is not right,
that's correct.
The bolt could come out, or the bolt could be too tight and not be able to go in and not hold things properly, right? So that could be a reliability issue down the line.
And historically, this is a good example of something that might have been sampled. Just these parts are coming at super fast, less than 30 seconds cycle time for every one of these parts. A person can't sit there and screw one of these thread gauges in all 9 or 10 or 15 or how many holes there are that quickly. Yeah. So they might pull 1 out of every 20 parts to check. Versus on this one, we can quickly do it with automation and actually check every single hole that comes in.
That's right. And the advancements that happen in the cobot, in the thread inspection gauge, the sensors that are there are very much like a human sensor. It has to sense the tension that it takes to screw this in to know that it's not actually threading the hole, that it's actually inspecting the hole, and it inspects it for depth. And the sensors that are involved with there are just like a human hand. Pretty amazing.
Yeah, that's awesome. So tell us what's going on in where you see the sort of bleeding edge of the future. Where do you see the future headed in terms of automation and in terms of measurement inspection that can help us?
Sure. Yeah. In the measurement inspection area, we're getting so much more advanced in software and what we can do with multi-sensor systems. The next step in that we're going to start seeing is AI becoming part of that picture, right? With the systems that are coming along and all the different tools and sensors that AI can wrap those into a nice bundle and deploy those tools to do the measurements properly. And then with the what I see happening, and Will, you can talk to that with the automation side, is that the AI is going to be able to communicate with both and be able to bring those two together. And AI looks at these things as just tools to get a job done, right?
So certainly some of the big improvements we see is regarding programming. More easily and quickly able to program. We're seeing smaller and smaller batch sizes. Time between tooling changeovers, part changeovers. So the robot and the programming being able to quickly adapt from one part to another. The software changes are a big part of that. So we're seeing lots of innovations in that side of things, as well as I mentioned earlier, the grippers. It's really easy to pick up, a hard rectangular part of some sort. Mm-hmm. But maybe a lot more difficult to pick up something that's
a loaf of bread.
Exactly, a loaf of bread, or maybe you have a part that's flexible.
Or a flexible rubber.
Exactly, things, something rubber that's really flimsy. So we're seeing more and more advancements in the sensors and the technology to actually grab those parts in a reliable way. Enables us to do more things with measurement.
And one of the things that I get most excited about, like a cool innovation, there's a whole lot of technology being spent in vision and being able to have cameras and lasers on systems now to where we can use AI to recognize where in the past we would go, okay, it's either there or it isn't there. Now we can kind of start to see what it is, and now we can start even making decisions on that and making better decisions on what it is.
Our vision cameras are getting good enough today. I liken it to going to a grocery store and you walk down the highway and you see all the different products there and you reach out with your hand and grab those products. And what are they? Well, AI is able to see those things when it comes to the manufacturing process, determine this is part A, this is part B, this is part C, and this is how I picked them up, and this is where I placed them. These are the programs that I use to measure those, right? It can make those decisions, so it's versatile, and it can do it on the fly.
Yeah, I was going to say that the vision sensors themselves have already seen vast improvement over the past handful of years. This probably will continue to get somewhat better, but the big changes we're seeing is exactly in the programming, and AI
software.
Augmenting the software, augmenting how easy it is to program those things. A person can certainly sit down and manually program these things, but if through the software being easier to use, it can be programmed in 30 minutes instead of 6 hours. That's a big improvement to the usability and the how functional that machine can be.
So we go from doing things manually, sitting it on a shelf, and then we sit there with our hand tools and that kind of jazz, and then we go, okay, well, now we put it on a nice gauging system that's going to do it more quickly, so we get a little bit more efficient, but it's still manual. We're still sampling.
Yeah, we just motorized a manual process.
Now we're doing 100% inspection, so we can have that has a red light on it now, but we say, okay, we got a green light, it's good. Red light's not great. But then and in terms of the future, we start seeing things like vision and AI, we can start to optimize things and start to make things now we know that our production line is working at its optimal, which is kind of where we're headed. And that way, again, as consumers, we know that the products that we use are going to last a long time. They're going to be dependable on that. And it's something and most likely it was inspected and measured.
That's right.
That particular piece was.
Yeah, exactly. You talk about, as consumers, the things we use every day, automotive parts, lots of people have cars, being able to better inspect and verify that all the pieces that make up that car are what they're supposed to be. That goes a long ways towards making it more reliable, make it last longer. We're seeing more and more of that.
Yeah, that expectation will continue to get broader, right? As we as consumers, we expect that from the products that we buy for them to last long. Our customers that do business with us expect the same thing from our service. They expect our service to last longer, and we're using AI today to make our services and our offerings better as well.
And the people that manufacture them need to be able to do that efficiently, and then be able to do it so that they can also be affordable, that we don't have to spend tons and tons of money to get something that's 100% inspected. We just expect it.
That's correct.
Awesome. Well, thank you so much. That concludes our episode 15 of Innovating the Industrial World. If you like what you've heard, please comment below. If you have any questions, we'll certainly respond to that. Please subscribe and like the podcast. Thanks, everybody. Chris, Will, thank you so much.
Hey, thanks for
John.
having me. It was
Thanks
a
for
pleasure.
having us.
Thank you.
Yep.